Today we are going to be discussing wireless performance tips for broadcast and location sound. And to talk us through that, we have two fabulous panelists. We have Audie Neves from our Global Product Management Group and Ben Escobedo, who is on our Market Development team. Very, very knowledgeable gentlemen here to give us a lot of great information. And then diving into today's agenda, we're going to start by discussing RF propagation, basically how wireless travels. Then we're going to get into antenna placement best practices, an introduction to frequency coordination, and then, as I mentioned, that live Q&A. And so without further ado, let's get into the bulk of this webinar. Take it away, gentlemen.
Hello, hello. Thanks for attending. This is a very, very nice topic. And Ben and I, we spend many days talking to customers about this thing. So I hope you enjoy as much as we enjoy talking about it. Basically, the main topic about RF propagation, and this is why we are talking about that first, because that is extremely important. The first rule of a receiver is that I need to see something, right? The receiver must have something to decode. And if my signal is not getting to the receiver, then of course we will have issues. It's important to remember that the so-called electromagnetic wave has two components. One is electrical, the other is magnetic, as the name stands. And in order to attenuate or absorb something, the material must conduct electricity. So if I have RF going through wood, for instance, something like that, plastic, it's be almost like transparent, so you have no issues at all. But if it's anything metallic or a semiconductor or anything, or even big bags of salty water called humans, we do absorb radio frequency, right? But there's not that easy, because the way that they absorb or they reflect radio waves depends on the size, the physical size of the wave. We're not going into much details on how to calculate that. We have a great course on the Shure Audio Institute if you want to take the master class. Tim and Gino, they go through all that, on how to calculate and everything. But let's imagine that, give it or take, a UHF wave will be about 2 feet long, right? 50 centimeters, 2 feet long. The way that the obstacles work with radio frequency depends on the size of the wave. So if I go to the next slide, we will see that my wave, when it goes to a metal obstacle that is smaller, that is bigger than the wavelength, part of it will be reflected, right? And as you see above and below the object, my wave goes through easily. And so that's when my obstacle is larger than, let's say, my 2 feet of my wavelength, right? So if I go to the next one, I'm using a very small one. So basically, even when I hit direct the obstacle, my wave goes through it because it's smaller than my wavelength. When we talk about openings, we have a similar effect. Basically, let's say that I have to squeeze my wave through that opening. So if the opening is bigger than my wavelength, the wave will go through, not a problem. But in the next slide, if the opening is smaller than my wavelength, what will happen is that nothing goes. And this is a very, there's an everyday example that we have, which is the microwave oven, right? The microwave, it's a 2.4 wave, it's about 4 inches long. And if you see your microwave in the kitchen, everything is metal. So the microwave bounces everywhere. But we have the glass in front of you, and the glass would be transparent. Right? But if you pay attention, there is a small net behind that glass. And the holes in the net, they are big enough for light waves, which are very, very tiny waves. But it's small enough for my microwave. So the microwave, we see that door as a solid object. And the same thing happens when I have my nice brand new wireless microphone and I'm working on the ballpark and there's a chain link fence between my microphone and the receiver. You know, with those, I don't know, whatever, 2 inches square versus my 2-foot wave, there's nothing that goes through. So keep that in mind. That's a very important thing. And this slide is important because we see many of the frequencies that we can have wireless in the US. When you go down in frequency, your waves get longer. When you go up in frequency, your waves get shorter. So a UHF wave would be around 2 feet. Your VHF wave may be about 10 feet. Your 2.4 wave may be about 4 inches. So keep that in mind because the same obstacle may be different depending on what frequency range you are working with.
A great point, Adi. If I may add, the not just like chain link fence of like a baseball backstop, but if our location sound friends, for example, are doing a shoot in an older house or something, there's maybe some metal in the walls or some lath for the plaster or something like that. Those kind of hidden things can really stop that signal, and you're not getting the range that you expect. Additionally, there's this chart here showing the VHF all the way up to the Wi-Fi and higher. As you go up in frequency and higher the frequency, you need more power to push the same distance that you would normally get with a lower frequency like VHF. So there's kind of a trade-off there between push a signal in the Wi-Fi range the same distance as UHF. You would definitely need more power behind it to make that happen, and hence why UHF is the sweet spot between manageable wavelengths, short antenna lengths, and of course getting the most bang for your buck as far as power consumption is required.
Cool. Can you take the antennas, Ben? Let's
Sure. Let's talk a little bit about antennas. We're talking about wavelengths and so forth. It's kind of basics, and it may bring you back to those that remember, TVs with rabbit ears or even boom boxes with antennas on them and so forth. But talking here, this slide, we're talking about antenna polarization. And basically, as a rule of thumb, wireless devices work best when the antennas match polarization. So, for example, that body pack looks like a ADX1 there on the left. If the antenna is vertical, ideally the receiver antenna should be vertical to catch that signal, and that will give you the best performance. If one of them is tilted for some reason, you will get less wave propagation and it won't be received at the same strength. Now, this is ideal circumstances. We have to keep in mind that not just, the signal isn't just going from one point A to point B, it's going everywhere and maybe ricocheting around the room and bouncing around and causing reflections and things of that nature. So additionally, you're never going to keep a talent stiff as a board, always walking straight up and that antenna is pointing the right way. I mean, real world, dictates that it's going to be kind of a variable. So with that being said, you want to try to orientate your antennas the best way to be more apt to catch that signal. Hence the classic 90 degrees, or it's 90 degrees like a square, but if it's like a V, same difference, you're kind of splitting the difference. If you're getting a great signal in one orientation, or it also is getting a great signal if it's 90 degrees out of phase, hence the very popular rabbit ear setup. Not saying it's wrong, but a lot of people will put their antennas vertically, on the back of this, right in the back of the unit, and that can work, but you got to think, if one's not working in this orientation, the other one probably isn't as well. So hence the kind of split 90 degree or the V shape. If we go to the next slide, kind of dive a little bit deeper here. Speaking of polarization, a lot of the antennas in the market, and especially ones that Shure manufactures and also Professional Wireless, which Shure distributes as well, make these antennas helical or circular polarized is a common term for these. And the beauty about these antennas is that they're continuously like a corkscrew. The way that if you look closely on especially the Touring Series helical and the traditional 88.9, those are kind of in a twist. and they're available in both right and left-hand options. But basically what's happening is that it really doesn't matter which orientation that wave is or how it's polarized. This type of antenna is really going to pick up in just about all of the directions. So it's quite a problem solver, if you will. The main difference is, as a rule of thumb, the longer the antenna, the more gain you have, and also the more directional it's going to be. So you would expect something like the HA8089 to have a further reach at the expense of more focused pattern. Whereas something like the Touring series helical and the 8091, those are going to be maybe a little bit wider of a dispersion pattern, but still have the same great corkscrew approach and trying to capture that polarity no matter what happens. The main difference, if you're curious about the TS series or Touring series vehicle, the 8091, they're almost identical. It's just that the TS series is a little bit more low profile, and as you notice, it doesn't have the dome over it, so it's easier to pack up and put into a case and stack on top of each other rather than the 8091. But all three of these antennas are in constant use, and they work very well for all purposes. They're great problem solvers. Additionally, talking about parallel surfaces and such, Adi was mentioning these are electromagnetic waves, so metal objects are obviously something to watch out for. But one thing that you may not think about is a lot of times the antennas themselves, they do have metal in them, and these are dipole-based antennas, and they do have metal on both sides internally. And if you put a lot of antennas next to each other, you're basically putting metal in between other antennas that are trying to receive a very small or tiny signal. So parallel surfaces, not just walls or metal structures or the rack itself, but the antennas themselves can be a problem. And hence, why we always encourage, if you have more than a couple systems, to look at an antenna distribution unit to simplify your setup, make it cleaner, and make your application work better. Okay, what do we got going on here? Placing antennas above obstacles. The basic rule of thumb, if you're not getting enough reception, the higher the better, of course, within reason. Adi was mentioning, big bags of salt water or the human body itself is often a problem, especially in crowded environments. So as we see, this sound mixer here has the antennas up high, and it's kind of shooting over everyone and trying to get the best line of sight without any obstacles in between. So the higher that you can go with your antennas, within reason, the better the propagation. We also see the antenna selection here they're using is what we call an LPDA, or log periodic dipole array. These are directional antennas, and they're very good at focusing like those helicals as far as what's in front of them and not in the back. So of course, they're not expecting the talent to be behind the sound mixer here, so we're going to choose an antenna that's just looking forward and rejecting what's coming from the rear, and that often will help matters out significantly. Speaking of body attenuation here, we have a body pack transmitter on the back of the body and then the receiver in the front. And as you can expect, of course, it's going to be a tough time going through that physical medium of the body itself. In real world scenarios, as we mentioned previously, you're going to get a lot of reflections, and especially indoors, the wave is going to bounce off everything, the walls, the ceiling, any other objects in the room, and find its way back to that receiver. But as you can see from the chart here, you're going to definitely get some sort of reduction if you're trying to go through the body. So something to keep in mind, if you're going to be putting a pack on a body, where am I going to put my antennas for best reception? Perhaps the sound mixer would be better off on the side of the set, or if you're hanging antennas in a broadcast studio, it might be better to put them behind the talent where the packs are going to be most of the time, rather than trying to go through the body or rely on those reflections around the room. Same thing applies if you're doing a production where you're hiding like the ADX1L micro body pack in a wig, for example. You're going to try to maximize that capture without having to go through the body for best performance.
Yeah, there's one thing interesting, and a lot of people ask me, like, I've used my wireless at church and I never had an issue. Why you are so worried about it, right? And it's interesting because if you select, and we talk about frequency coordination now, which is basically selecting what frequency you use. If you have a very clean, no noise frequency, you can take a 6 dB, a 12 dB hit, and there'll be no problem. Your system will still work fine. But imagine if you are working right at the edge and any hit can cause a drop off. So that's where all those antennas best practice really will save your life. And nowadays, with the environment the way it is, it's almost like the everyday. The norm is not to have a clean frequency, right?
Absolutely.
So the basics of frequency coordination, first and foremost, every system must have its unique frequency. So you can't share frequencies unless you are in a large environment. And we've seen people sharing frequencies when they're working with 300 frequencies, 400 frequencies, and they know what they are doing. There's a very specialized professional coordinating the frequencies, and he knows when. But as a rule, we don't use the same frequencies. Each one has its own frequency. We have to consider the total wireless needs. So I cannot go to an event and say, I'm responsible for the microphones. Well, who's responsible for the in-ears? Is that anyone covering the event? Is that a broadcast? If I'm working on my set, is that anyone shooting on the studio 2 doors from me, and what frequencies they're using, right? So we have to have all that knowledge so we can make the best decisions. And then we will coordinate frequencies. So most of the time, if we're getting into a big event or an organized event, say, people will have a frequency coordinator, or at least a frequency coordination that has been done sometime, and they have a list of frequencies you can use, for instance, on this stage, and there's a list of frequencies you can use on the other stage. Ideally, even if you're working in a broadcast studio, you should do frequency coordination as often as you could. It's not practical in most cases to do like daily or anything, but don't think that the frequency that you use today and you're using a month from now will work, because it may not. When we work on the frequency coordination, when I mean that you have to know all your wireless, is because you have to be able to coordinate for all your wireless. And believe me when I say coordinating frequencies is way easier than coordinating people. When you get someone, for instance, let's say that you talk to the ENG crew that show up, and you say, hey, I'm coordinating my frequencies and I will give you a new frequency. And they said, no, I'm not allowed to touch the frequencies in my system. Well, then what frequency you are operating now? Then you get that and you treat that as an unmovable frequency in your coordination, and you coordinate everything around it. And sometimes we have not only that, but you may have some specific usage that you can't move that frequency, but you must be able to know and work with all of that. There's 2 points that will create issues for us. Outside interference, which by outside interference, I don't mean a TV station or the classic things, but it could be just a wireless that I don't have the power over it. I don't have the control over it. That will be considered an outside interference. And also my own systems, our system to system interference. And we have a very nice video that show why we have to be worried about them. Let's go to the next one. This slide shows the same mic in 3 different frequencies. And remember, a minute ago when I talked that you can be working on a clean frequency or very, very in a very noisy environment that anything can take you out. So on the first example on the left at the 540 megahertz, and those are all hypothetical numbers and situations, right? What I would like you to pay attention on that is that the green part, which is my carrier, it's way above my noise floor, which is the gray part. In the 550, in this specific scenario, I have some noise. The some noise may be someone using my frequency 2 stages down, and another sound stage, and another, but it's far enough that it will not take my mic out, but it's close enough that I will not have the same range. So in that case, in my example, I have like a fifth of my range. And this can happen, all the time. If you don't do your proper frequency coordination, you totally may lose a lot of very precious range. Then if I go to the third example on the right, it's the equivalent to operating on top a DTV channel. I did not do my coordinations. I did not know what TV channels were on, which of course you must know what TV channels are on everywhere, because you're not supposed to fire up another transmitter on that frequency. But in case you turn on a transmitter that is the same frequency as a TV station, you won't get much range from that. It may work, but as soon as you move, you'll have a dropout. Now we can go.
Absolutely. Yeah, Eddie, that's great. If I add a couple of things, I mean, you have to picture as you go farther away with those frequencies or those spikes, they're going to lower, and the noise will stay the same. So that desired or the green signal that you really want to make everything happen is going to reduce. And as Eddie was mentioning, that 561, if that's what it is now, as soon as that talent steps farther away, you're not going to get much range before it shuts off. We'll touch more about in a little bit, but additionally, in the digital world and analog as well, they're both, the signal noise ratio or the carrier to noise ratio is of utmost importance. With analog, as you reduce that green portion or the wanted signal, you're going to get worse audio quality, and it'll be audible. You'll hear it. It'll be not as good as you expect. And with digital, if you get to a certain point, it won't work. It'll shut off, and you'll have nothing. So it's utmost important to be as on the cleanest noise floor as possible with frequency coordination.
Yeah, and this works for, like Ben said, everything, like analog, digital, any brand, they all follow the same physics, right?
Yes.
There's one thing that is interesting on our Axiom digital line. We have a measurement called Q, which is the channel quality, and it basically measures what you're seeing on the screen. So on the left one, I will have like 5 dots on my Q. On the one in the middle, I will have like 3 dots. On the one on the right, I'll have like 1 dot almost going dark. And even though the 3 of them will have full RSSI, so the meters that measure the intensity of your RF signal, they will be all up in all the 3 situations, but the signal quality will go down. That's our way to help the user on a digital system to escape or to avoid this kind of situation. Now we can move. This is a spectrum analyzer. If you're not very familiar with that, on the y-axis you have intensity and intensity versus frequency, and it shows that in this case the situation is not very good. It's very busy. The big square blocks. If you go to the next slide, the big square blocks means TV channels, and the skinny picks you see are other RF devices that are there. There's a couple ways to understand where the TV, or to know where the TV channels operate. It's very easy to fight that interference because they don't move. You got to have an FCC license, and the FCC license for your broadcaster will say what frequency you can use and all that. So they're always in the same place, but they change from city to city. So we have tools, and there's a slide later on about the frequency finder where you put your zip code, and it tells you what TV channels will be on your city. So that's a good starting point for to do your coordination. Talking about the other aspect, right? So our own systems. One thing that's super important is how far or how close my frequencies can be from different mics. In this case, I have one at 499.6, I have one at 500, I have one at 500.4, which is most likely a high-end system, which is kind of the minimum that you can get. We can play some tricks with the digital systems. We can get them closer as far as like 250, and they still operate well. But basically, you must keep a distance between the frequencies. Most systems, they have steps, and they will tell you what to do, and Ben will show that on the groups and channel feature. But just make sure that you don't have like 500 and 501, and well, they will show in each other's meters, so it will be very easy to see, but you must have a minimum spacing.
Correct. Yeah. Most of them are 350 to 400 kilohertz is typical. If you're curious about what those numbers actually are, you can go into Wireless Workbench into the equipment profiles and look at it there, especially for Shure devices and some third-party or other manufacturers as well. Of course, you can contact other manufacturers to see what their recommendations are for minimum spacing, to see how close you can get them together and still work reliably. We do have some cool tricks, so we can make them go really close together with things like our high density mode and Axiom Digital and so forth.
Cool. So we talk a lot about digital, but there's a lot of analog in the market. You see a lot of IFBs in analog. You see a lot of, or if not all of the in-ear monitor systems in analog. There's a lot of analog systems there. And it's not that you really have to treat them different, but in order to take the big advantage of the digital, it's good to understand how the analog work. So if you go to the next slide, this is a video I've done quite some time ago, and I will explain what was going on. So Cheryl can play the video. Cool. So in this video, you see that on top I have the two channels 1 and 2 that are the Axiom Digital. They'll be at 600 megahertz, and the 2 will be at 601. On the bottom, I have a ULXD with 4 channels, and the 4 channels of the ULXD will be 598, 599, then 602 and 603, which are, I don't have any transmitter on those frequencies, right? So I only have 600 and 601. And on the video, I spoke slowly, and so now we're going to see when actions start happening. Basically, I'll turn on those transmitters. Those transmitters are from our UHFR series, the UR series. So this one is operating at 600 megahertz. And then if I turn that off, you see that the carrier goes down. And then when I turn the 601, it shows up a little bit more to your right. All right, so one is at 600, one is at 601. But I can see in the bottom, my ULXD is clean. There's basically no RF going on over there. So those 2 frequencies, they are good to use because they're not interfering. But when I turn both of them at the same time, check what happened with the ULXD. It light up like a Christmas tree, because you see those extra peaks that showed up to the left and to the right? Those are the ones that are being picked up by the ULXD. And they are a process that when 2 transmitters are close together, one interfere on the other, and they rebroadcast those spurs, those we call intermodulation products, or IMD. If I put them like I move one transmitter away from the other, and you see that the ones on the edges, they basically disappear. We call them 5th order. And now I put they really far away, and the very close one we call the 3rd order intermods, they also disappear. And you can see on the ULXD that is clean. But if I bring that transmitter close by, the 3rd order appear. And then if I put them really, really close, then the 5th order intermods will appear too. And there's a mathematical formula for how to calculate them. They will always appear on the same place, which is basically on the same difference of the two frequencies. So if I have 1 megahertz between the two frequencies, they will go 1 megahertz up, 1 megahertz down. So it's very, very important to keep your coordination away from where those intermodulations may appear, because you may have, two singers, and when they come together because they are singing a romantic duo, suddenly you don't have backing vocal microphone anymore because they were right where that intermod would appear. So this happens on analog and digital, but if Cheryl could cue the next slide, we can talk about the difference between the analog and the digital in terms of intermodulations. Also, while we're checking the new video, what I want to talk about is power, is the transmitting power. The higher the power, the way higher is my intermod. The amplitude of the intermodulations go into the square of the increase in power level. So they increase way higher when I increase power. So that's why we say never use a high power. You can't use a high power transmitter in an environment where you need multiple transmitters. If you use a low power, the intermods may go below the knob.
Sorry, Adi, I started the video and we muted your audio accidentally. So
Oh, I'm sorry. Don't worry.
No, it's my fault. I'm going to restart the video here. This is the second video.
Cool. So now the video is playing. What I'll show is that how the digital versus analog is different on that. The circuits on the digital system, they must be very linear, so they produce very little intermods. The intermods are physics, they will be there. But here's the analog again, same way we show in the previous video. So I have them probably a couple inches apart, and I can easily see the third order intermod peaks and a little bit of the fifth order intermod peaks. But because of the amplifiers, especially on the digital systems, are conceived to be very linear, we don't have a lot of interference. You see those two transmitters, those are ULXDs. They are basically at the same distance, and I cannot see on the spectrum analyzer, I cannot see the intermod peaks, which doesn't mean that they're not there. They are there, but their amplitude is so small that will not affect too much.
Yeah, they're basically within the noise floor, so they're not really a problem. People ask all the time about the difference between digital analog and intermod. It's not because it's digital or magical or anything. It's, as Adi mentioned, it's the amplifiers inside are so linear because they have to be for the digital to work, and so precise that they're not going to create the distortion, and you won't experience all those intermod products.
Exactly. So, but you have to be careful, because if you push a lot of power on the digital and they are very close to each other, like one pack on top of the other, you may have a little peak in there. So we don't say normally that you don't have to worry about it at all, but in practical aspects, in most circumstances, you can. You can forget about the intermods on the digitals. But keep that in mind: power, low power, and if you can calculate and avoid those intermods, that's the best thing you can do. Cool. So next one. Okay, the wireless frequency finder is the tool that we have on the Shure website, the shure.com/frequency, where you can type your zip code and it will tell you what TV channels are on your zip code. Keep in mind that we take that from the FCC database. So let's say that I there's a church and they have an FCC license to broadcast, but their TV station is not operational. That frequency may be clear, but you would not know until you check that, and it is a restricted frequency anyway. So you should follow that list and not operate in any of the occupied TV channels.
Yeah, additionally, especially in major metro markets in the US, you have to be aware of the public safety bans, and the wireless frequency finder and wireless workbench program will tell you about those and make sure you're not operating in those lower UHF channels, 14, 15, 16, 17, and so forth.
Ben, do you want to take it over?
Yeah, sure. So when Adi was talking, this problem about intermodulation has been since the beginning of wireless microphones and prior to that. Historically, it's been an analog issue, although best practice will dictate that you should, calculate for intermods anyway, if you can. Now, if you have a high channel count in a very congested environment, it may be best to, do whatever you can to make it work. And even some in analog, we kind of massage those parameters to make the system work. That's the name of the game. But in order to solve this problem, Shure and other manufacturers have created pre-programmed groups and channels of frequencies that will be automatically compatible with each other. Now, there's no guarantee that they're going to be clean and free in your particular location or your environment, but all the channels within a group, it'd be like group 1, channel 2, and so forth, and group 2, and there'll be a whole matrix or a list of these frequencies. These are pre-programmed into the majority of Shure wireless units, and as long as you keep in the same group but use different channels, that is the best practice for that particular frequency band or range that you're using with that same device. So again, if it's a G50 range, for example, maybe you're going to use group 2, channels 1 through whatever. As long as those channels are clean, those channels are basically been pre-calculated by our engineering staff to not have intermodulation issues. The intermodulation products that may result from using those channels within a group are going to be perfect, and you're not going to have intermod problems. Will you have external interference problems? Maybe. Will there be a TV channel in some of your stuff? It could be. But as far as the systems from system to system or your own system to system interference won't be a problem. So that's in the majority of Shure wireless, and other manufacturers follow the same suit as well. They have their own scheme for that. In addition, we've been seeing more lately about, you can make your own custom frequency list, and we'll touch base on that in a little bit, but there may be some use cases where you want to make your own custom frequency list to either fit within a certain range. If somebody says, hey, you can use your wireless, but just make sure that you're between this frequency and this frequency, you can do that. Or a lot of our location sound friends are using filtered antennas out in the field to give them a little edge and a little bit more reduction of outside interference. You can make custom frequency lists and import them onto the hardware so that you can do a scan quickly between a certain frequency range, maybe the range that you set your filter. You already know that you want to be operating between this little pocket of frequencies. Well, let's make some custom frequencies that are compatible. And then when you get out in the field, you can do a scan really quick and not have to worry about intermod or anything like that. So next slide, please. As we look here, we call them groups and channels. So for example, group 1, channel 12 here will be a pre-programmed frequency within this product. A lot of these frequency charts, if you want to geek out and you are interested in it, they're published. We have the frequency matrices laid out with what exact frequencies they are, and these are permanent. They're in the system. You're not going to change them. You can't delete them. And they'll be, depending on the system, there could be maybe 5 or 6 groups, all the way up to tens of groups. And within that group, there could be tens of channels. More than 20, 30, however many channels as well. Again, as long as you follow the same group number and different channels within that group, that is best practice. What you don't want to do is mix and match groups like group 1 and then group 2 and group 3, and then it just all goes out the window. And I know I touched on it briefly, but it's worth repeating, is that this groups apply to the same frequency band. So if you're using like a G50 range, for example, that would be group 1. If you're using a different range, J8A or something else, then those groups are not compatible. group 1 is not compatible from the J range to the G range and so forth. This is just with one specific range and one specific system. If you need to do more advanced or kind of different groups or different frequency ranges, you might want to reach out to Workbench or for some assistance there to kind of make everything a custom coordination, if you will. But this is the proper use. We show here on the right-hand side, group 1, channel 1, all the way to group 1, channel 4. These are going to be pretty much intermodulation free. Again, you still have to do a scan to see if there's any activity or outside interference on these channels, but they will be guaranteed not to have intermod products. Additionally, as a rule of thumb, or kind of a loose rule of thumb, a lot of the groups and channels have been pre-engineered so that the first 8 within a group will fit into one TV station or TV channel. So, and here in the US, TV channels are 6 megahertz wide. Europe, they're 8 megahertz wide. Those first 8 channels should typically fit within one TV station. So if that TV station is clear and free in your area, then you can expect, most likely that the groups, channel 1, 2, 3, 4, all the way up to 8 will be the same and follow suit. So it's kind of a nice little thing there. But as we'll show in the built-in group scan on the channel scan, there are tools that will help you sniff or scan these groups to make sure that they are clean. Next slide, please. All right, so we're going to kind of go through here a group and channel scan, the differences between using Axient Digital as a test subject here.
Many Shure wireless receivers contain powerful scanning functions, including the group scan and channel scan features. In this segment, we will use an Axient Digital receiver to perform both a group scan and a channel scan. While we are using Axient Digital for this demonstration, the process is similar on most Shure receivers. Keep in mind, this will take the channel offline for microphone use while scanning is in progress, as we are using the radios in that channel to do the scan. A group scan is best utilized to set up an entire wireless system in a new location, while a channel scan is useful for scanning and replacing one or more channels without having to redeploy all frequencies. First, we will choose the receiver channel to use for scanning by pressing the channel 1 and then selecting the group scan item in the menu. A message will advise us to turn off all transmitters during a group scan. This is so the receiver doesn't think those transmitter frequencies are interference. We will press the Start Soft key, and the receiver will scan all available groups in every channel within those groups. The receiver will then report back to us the best group to use with the most open frequencies. Now that the scan is done, we see the receiver suggest group 5 as having the most number of open frequencies. With Axient Digital, you can browse through the various groups and see exactly how many frequencies are available, along with a brief description of the various groups and what the group is. As we go through the groups here, we see, group 5 is full range max channels, group 6 is more robust, and there's even a user group that we loaded which may be useful for scanning within a specific frequency range. We'll select group 5 as that is the one with the most available frequencies, and then pressing the soft key deploy. This will deploy all frequencies to networked receivers. If you have a ShowLink access point and ADX transmitters, the changes will go into effect immediately on your transmitters. If not, you can simply infrared sync each transmitter to the appropriate receiver. That's great. However, what do we do if one specific frequency has an interference problem? While we could perform another group scan, it would be a hassle to have to resync every transmitter to the receiver, as group scan will change frequencies across all connected channels. This is where the channel scan excels. Channel scan will replace the affected channel with a new frequency without disrupting all of our other established frequencies. First, we select the channel to change and navigate to channel scan. In channel 1, for example, and channel scan. We will notice that the group indicated by G is the same number, 5, as we chose during the group scan. By using the Find Next, Find Best functions, we can select a new clean frequency. Once satisfied, we can deploy this to only the channel by pressing the flashing green Enter button. Immediately, we notice the channel has changed. Since it is still in the same group number as the rest of our system, it will be compatible.
So there you have it. The difference between group scan and channel scan. You should always do a group scan whenever you get to a new location or you want to reset your entire system and so forth. And channel scan, of course, is extremely useful if you have one problem channel and you just don't want to have to go get all those packs, all those mics back and infrared sync everything and reset everything up. So channel scan is kind of a surgical way of just taking one or a couple channels and changing those frequencies that may have issues and so forth. This is actually digital we're talking about here. This also applies to just about every other wireless system that we have that has the group and channel scan abilities, UXD, and so forth. So hopefully that kind of puts it in perspective of the difference between the two, the group scan and the channel scan, when you should use them and how useful they are. It can definitely save you a lot of time and make sure that your system is going to be intermodulation free and reliable. Next slide, please. So as you noticed in the video there, I did preload a user group in Axiom Digital, and most compatible that you can systems that you can load predetermined user groups are typically 6 user groups with up to 60 frequencies per user group. And I touched base on this earlier, but to talk about it again, just if you have a need to put frequencies in a certain area, or maybe you have specific frequencies that you want to load in there, if you're sharing, kind of picking up the same pack on multiple receivers, maybe a use case, or we're using filtered antennas, or a lot of broadcast facilities also use filters on the front end to make sure that each studio is in a certain filter range. Well, the user group is very valuable, and you can load those into the system, and the best part is that they'll be on the hardware, and no matter if you have workbench access or anything else, you can do a scan and choose those frequencies in the user group, and they'll always be there until you get rid of them. You can even share those user groups across network devices. So if you get them on the first receiver, you can share them to others and so forth. We find more, especially in my own experience here, I've been finding more users interested in the user groups and custom frequency lists, especially our location sound friends that are going out, being portable, being quick, fast on the move, maybe not have room for a computer or workbench, and they want to do scans quickly and get to those preset frequencies within a filter range. User groups are the answer. And you basically just create a custom list in Workbench, you save that file, and then you can import it to the device over the network. And once it's on the hardware, it's on the hardware. So this slide here, basically, we touched base on this already, but if you need to make those custom use cases, you have multiple frequency ranges, you have different systems from different manufacturers, you have very specific needs to maybe not be on certain frequency blocks or certain ranges because there is an adjacent studio, or the coordinator on site told you can't be on those. Well, Wireless Workbench can do all that with its very hardy inclusion and exclusion regions. So you can block out not only TV stations, but say, hey, only put my wireless in the specific frequency block or a certain range. Watch out for this frequencies here, stay away from this, all that. And you can do it very quickly and push it right to your system. So anytime you need something a little bit more granular control versus a group scan, you should be looking at the frequency coordination tab in Workbench, which is super powerful and awesome. So talking about multiple zones, I brought this up because it's something to think about. Adi mentioned, what if you have a broadcaster in New York City that has, 300, 600, 900 channels of wireless between comms and IFBs and wireless? Well, you have to start thinking and planning out your location as zones, and reusing, or the technical term for reusing frequencies on the same site would be called multiplexing. If you have a studio on the 6th floor with a late night talk show, and then you got another studio up on the 12th floor, for example, they're far enough away that never will they ever have interference with each other because of the distance and all the concrete in between. Maybe you can start reusing those frequencies. In this particular example, if you have frequencies in block A, or that little box A, maybe it'll never reach block D. So you can treat A and D as completely separate coordinations. But however, because H and A are adjacent to each other, maybe you do have to be careful not to, step on the frequencies in between the studios, and also be concerned about intermod products and things like that. So just kind of start thinking about, if you are in an area where there's multiple wireless users in different areas, different rehearsal studios, different shoots on a set or a sound stage or a studio out in the location sound world, broadcast studios that have, adjacent studios next to each other. These are things to think about when you're setting up your frequencies about, are they ever going to have problems with each other? Are they far enough apart where they may not have problems with each other? And not only thinking about it visually, but, again, Wireless Workbench has a great set of features to do multiple zones, and you can, tick boxes about which zones interfere with which zones and what to ignore, and create a very nice, very complex, frequency coordination, and then of course quickly deploy it to network Shure devices. So just something to think about when you are doing whatever you're doing out there, and you're wondering who's next door using wireless microphones. Will they reach that far? Maybe take one over there and see how far it goes. And if you are getting signal across or through that wall or through a couple floors up, do a walk test and see if it could be an issue. Next slide, please. So, I was talking to our friend Henry Cohen, CP Communications and RF Guru Extraordinaire, and I think it's important to talk about being a responsible RF user. A lot of times, this is something that's not very well thought about until the last minute. Especially, we're talking about televised sports events or press events or corporate reveals and all that kind of stuff. And there may be some, especially ENG, electronic news gathering crews, or location sound crews that just show up and they bring their wireless, and we've always been using this, and they're not really concerned about the frequencies, and they just fire their stuff up and can cause problems. I mean, we've seen this at the highest level with some, the major sporting events of the century and things of that nature, where people just bring stuff and they don't think about it, and they just turn it on and they start causing problems with a halftime show or something of that nature. It happens all the time. So, before you go to the event, this slide was talking about, make sure that you talk to the technical director, the manager about, what's going on with frequencies, who's in charge of it. Do I need to talk to anybody? Is somebody coordinating the frequencies? Is it a free-for-all? You shouldn't just go in and fire your stuff up without at least asking those your basic questions, especially if you brought your own stuff or your own equipment. Adi mentioned earlier, there could be house equipment there at that venue or that location that they're using for that keynote speech or something, and you bring in your portable camera wireless or your location sound rig or whatever, you could have some serious issues. And a lot of times this has happened in the past, so they are prepared for it, and there's somebody to talk to, whether it's a sporting arena or headquarters of a major electronics company or whatever the case may be. At least ask and find out if it's permitted to fire up. Maybe they won't care, maybe they don't have anybody, or maybe they do. But you should at least be a responsible user and save a little egg on your face, because you probably, if you don't ask and you get shut down, you'll probably be using that SM58 and the XLR cable you brought as a backup, because you won't be allowed to use your wireless and so forth, or worse, be asked to leave if you're not obeying the rules of the venue. But try to think about others. Wireless Workbench has some great tools about being a responsible RF neighbor. If you see other wireless spikes in the spectrum, trying to stay away from those. I don't know what it is, but you know what? For their sake and our sake, I'm just going to steer clear and make sure we don't have any interference between us and whoever that may be. Yeah.
One thing that I would add, it's interesting that not only the Shure products, all Shure products, they have this feature, but many other manufacturers do the same. You can turn on the transmitter without actually transmitting. It's called RF muted. So in the most Shure packs, you turn it on holding the exit button, and we'll go into the safe mode or RF mute mode depending on the product. So just read your manual, make sure you know how to do that, because at one point you have to turn it on, at least to program the new feature, the new frequency, right? So it's a very handy skill set to have.
That's a great point. Yeah, that feature is put in there on purpose for exactly this type of deal. You're at a festival, an event, a award show, and you need to turn it on before you change the frequency. How do you do that? Yeah, hold down that exit button and turn it on, and you should boot up into RF mute mode. Absolutely. That's great. So yeah, please think about this. And then we're looking at here is a very cool feature of Workbench, and it's been implemented fairly recently, called Timeline. And again, it's part of the free suite of wireless Workbench tools. It basically is a recorder for the performance of your system, and you can easily start it by clicking on Auto Timeline and that button in the top. One click with that button will record all active channels. Now keep in mind, it's not recording the audio. You're not going to get a WAV file. What you will get is a historical performance that's time-stamped of things like from top to bottom, the purple quality meter that Adi was mentioning for Axiom Digital, the blue link lights on A and B, or if you're using Quadversity, A, B, C, and D, the RSSI or signal strength of each antenna, any interference events, audio levels, again, not the wave, but showing audio as you're talking, battery life, and ShoLink connectivity status. So this is an extremely important tool to kind of troubleshoot what happened. Of course, I heard a dropout. The technical director came down and started yelling at people and what happened? Why did the lead microphone cut out on the stage and so forth? We want to know, well, if you have timeline running, maybe one click before you set up your system, let it run in the background, you can go back to that exact time, minutes and seconds, and see what happened. Maybe the battery was flat, or there was an interference event, or there was a unplugged mic cable. Everything looked great, but there was no audio coming through because the mic cable got disconnected. It's a very useful tool for kind of post-mortem diagnostic. If anything, it helps you not just deflect blame, which it can do as well, but makes you better for the next time. What happened? Why did it happen? How can I do better next time to make sure that the next session goes well, and we can prevent things like this happening? I tell users, when you set up your system and you got Workbench running, right from the beginning, just start the timeline and let it run in the background. You can close the window; it'll still be a red light will be going on the Workbench showing that it's recording. Takes up very little hard drive space. If everything went well, great. Throw away the file, close it out, X out. But if you did have a problem, you can save that file for your own records, and you can even email it to a colleague, friend, or Shure associate to find out what happened with my system. Why did I have a dropout? Well, very clearly it shows the battery was going flat and it kind of died there at 1034. So just keep in mind that this is a very useful tool. If you're using Workbench and you're on a show anyway, one click of the mouse is all it takes to kind of cover your behind and make this go. I recommend it highly. And with that, we'd like to open it up for any questions that may have come in during the chat.
Fantastic. Lots of great information. Thank you so much, gentlemen. All right, kicking it off here with this first question. Is the frequency finder only for the US, or is there options for Canada or international areas on our website?
Ooh, that's a good one, Adi.
That's an interesting one. I know that on Wireless Workbench, we have a version of the frequency finder, which is not the online version. And that one has data for Canada, for Mexico, for, I guess, for Germany. There's some, not everywhere, but there's some countries that we have an international. I think that the frequency finder is US and Canada only, but I'm not sure. We'll have to check that. We may get back to you.
Yes.
Okay, great. Next question, is there a benefit to using 8 ULXD4 units and 2 antenna distribution units to take up 6 rack spaces rather than 2 ULXD4Q units that only uses 2 rack spaces?
That's a great question. I mean, there are official recommendations about the number of units that you can cascade with each other. So I mean, it'd be nice to put everything under a single pair of antennas, but the reality, there are some losses with the internal splitting that is happening there. So I believe, I forget if it's 1 or 2, Adi, for ULXD quads. I think I want to say 1, but it might be 2.
1, yeah, we recommend only 1. Yeah.
Same thing with Axiom Digital. So if you have a quad Axiom Digital, you can cascade 1 additional unit underneath. Can you do 3? Will it work? Probably, but it's not the official recommendation. So if you have more than that, you should be using some sort of distribution, UA845 or whatever antenna DA that you may have available for you.
Yeah, the other thing that you have to keep in mind, and it's very important, is that if you have them on the same band, or if they are in different bands. If they are in different bands, you cannot cascade.
Correct.
Then you must use a distro. So it all depends.
Great. Yeah, there's filters in there that would prohibit that.
Fantastic. All right, this next one, I'm not quite sure if it's a question or a comment. I'm just going to present it to you guys and see if you have any things to say about it. It says, plus 6 dB at paddle antenna is set for a stage of 22 square meter area, and Workbench indicates low RF with 10 milliwatts on the Axiom.
Okay,
It-
so
Yeah,
we didn't get really
there's
into
two parts of that question. Yeah.
There's two
Go ahead.
parts. So the booster on the antenna is only there to make up for cable losses or any splitting losses that you may have. So if you have 100 foot of cable and you have just call it 6 dB of loss, then you should put plus 6 dB at that booster to make up for the loss in the cable. It is not going to increase your signal the way you think it's going to be. A lot of people think that turning it up to 11 is great, let's crank it up and it's going to work. But if you recall back on that slide that Adi was showing with the green wanted signal and the unwanted signal, whenever you put a booster on that signal, you're not only boosting up the good stuff, you're boosting up the bad stuff. So proportionally, they just go up like that. You're not getting any performance increase. So if you are getting low RF, it's either your pack is having body absorption issues, the output power is not high enough. You might want to try high or higher power and reorientate your antenna. There could also be plumbing issues with the RF. The cable could be bad or it's not plugged in or something of that nature. So try all those things first. But again, most of the time that antenna should be left at 0 boost unless you know that there's a loss in that cable or any of your plumbing that would necessitate you boosting up to plus 6 or higher.
Yeah, it's rarely the occasion where the power is the issue, unless you're working outdoors. It's a huge distance. Most of the time, it's either your noise is too high, so your frequency is not properly coordinated, or you have an obstruction. And some of them, again, they're not very easy to see. Let's say if your antennas are in the middle of the lighting fixture, that may be blocking your RF. It's more like something like that, and of course a clean frequency, than power or anything else.
Yeah.
Great. All right. Next question. This person is using Samsung Airline 77 wireless, and they say they have 2 wireless units for vocals and sax mounted side by side in a single rack space. If the antenna on adjoining sides are crossed, will they interfere with each other with their receptive signals?
That's exactly what Ben showed when it said that there's the figure with a bunch of antennas. We have what we call the fencing of the antennas. When people put them side by side and stuff, that's not a good thing. If ideally you should put at least 2 feet between them, so you can do that horizontally or vertically, depending. But don't you get better reception. If you don't have problems and everything is working like that, perfect. But probably if you didn't, you wouldn't be asking the question.
I was going to say, yeah, I mean, if you're not going to use a distribution unit to kind of share antennas with that would just separate the units as far apart as possible,
Yeah,
practically possible.
I think that system he's talking about is one with the fixed antennas in front.
I believe so, yeah.
Yeah, so there's no way to replace the antennas or put this.
Maybe one at the bottom of the rack, one at the top, or higher up and farther apart would be ideal.
There you go. All right, and I think with that, we've gotten through all of the open questions. So if you do have a question that we didn't get to, or if it's burning a hole in your mind, you can always go to shure.com/contact and fill out our form there to get in touch with our application support team. We have a fabulous team of people that can answer all sorts of audio questions, and it's very easy to get in touch with them. Just fill out the form at shure.com/contact. And while I was saying that, we did get a couple of more questions. So gents, have a few more minutes to go through these?
Sure.
All right, great. If the RF world is set up in a corner of, say, a football field, is it advantageous to have the closet transmitter in a low power mode to avoid overloading the system, making it more even receive site?
The closet transmitter? I'm not sure if I.
Yeah, I'm not sure if I don't know if you're talking about when you are setting up a system, because then what people normally do is they use like a bread pans, they are aluminum, so put the mics inside of them so they avoid one mic to interfere with the other. Or if you're talking about one mic that is close by.
I'm sorry, is it advantageous to have the closest transmitter in a lower power mode? Excuse me, that was poor reading on my part.
Gotcha. Okay, closest. Yes. I mean, so if you're too close to the antenna and you fire up a wireless transmitter, you can have an RF overload. It's not the end of the world, but what will happen is the receiver will go into a protect state sometimes, and it will kind of pad everything down to protect the inputs of the front end of the receiver. So if and when that does happen, you can get reduced RF performance across the board for everything on that system that's connected. So Adi hit it right on the head. I mean, not necessarily putting it in low power, because then you have to put it back into normal again or high or whatever you're doing, but maybe the breadpan approach would be a better way of doing it, to kind of keep everything isolated RF wise, or simply just move farther away if possible so you're not too close to that antenna and lighting up all those red lights.
Yeah, I think it all depends on the application, right? If you have something that it's fixed, so you know that that transmitter will always be at, 10 feet from the antenna, but you need to get the other one that is in the other side of the field, and you are operating on high power, you definitely can put that, let's say, at a mid power, and that will be fine for you. You definitely don't want to leave the transmitter that is closer to the antenna on a high power setting, right? But it may be that even on the high power setting, you are not overloading the antenna. The big deal is no red LED, no red LED. If you look at the antenna, you see a red LED. If you look at your receiver, you see a red LED, something wrong. So somebody's sending too much energy to the antenna.
Okay. Next question. Are frequency groups unique to Shure, or are they the same across manufacturers?
Great question. In full disclosure, some manufacturers will call them banks instead of groups, banks and channels, and it's the same concept. Do those numbers correlate across manufacturers? No, they do not. So, group one from a Shure device will not be the same as group one or bank one from another manufacturer's device. These are custom calculated out frequencies using intermodulation tools, and guaranteed to work only with that same device in that same frequency range. So great question. I love where your head is at, but you can't just set group one on all different manufacturers' devices and they work together. It'd be cool if you could, but you can't.
And even the same manufacturer, like you cannot say that the group one for a ULXT is the same as a group one for the QLXT, or the different bands on the same, the bands are different, the groups will be different. So groups and channels work great when you have one band and one type of gear. If you have more than that, then workbench will be a better solution.
Yep,
That's
I was
right.
just going to say primary reason right there for wireless workbench.
Absolutely.
Great. Next question. If I'm using a digital system like Axient, will an analog system like Electrosonics Hybrid Digital over FM cause major intermods?
So just to reiterate, the point, the intermods are caused by the signal going back into the antenna. So you have a body pack with a transmitting antenna, and the energy is supposed to come out of it. If you have two body packs next to each other, some of the energy from the other pack is actually going back in the wrong way to that amplifier and causing those intermodulation products, distortion, if you will. So can digital devices be affected by analog intermod? Absolutely. Adi was showing that in the video. You fire up some analog and creating intermods. If those intermods happen to land on the same frequencies as an Axient Digital or ULXD system, then yes, those issues, you'll have a higher noise floor there, and you could have some dropouts and problems, even though the system is digital. Basically, what we're trying to say is that the digital products, the digital units themselves aren't going to create, typical intermodulation products that are going to hurt you, but they are affected by any intermod products that are created by analog devices. Absolutely.
The other thing you see is that when you use the same type of product, you have that Christmas tree kind of thing that we are showing. They are all the same amplitude. When you put an analog and a digital transmitter side by side and you look at the spectrum analyzer, the digital will not be generating much, but the analog will be generating. So they will be, one tall intermod and one very short intermod. So, but there will be some there.
Okay, great. Next one, weird question. We keep getting dropouts from our mics, and the distro company recommended adding a -6 dB attenuator. Can you explain why that might help?
Well, it's what we just talked, right? That there'll be too much signal coming on the front end, and too much signal will desensitize the receiver. So you may have dropouts for that. You may be over amplified somehow. You know, maybe you have a fixed an antenna that is fixed 12 dB gain, and then you're using a short 10-foot cable. Then you may have to put an attenuator to get rid of that gain on the antenna instead of changing the antenna to a passive one or something like that. It's basically there is a gain structure in your antenna system that is not properly set.
Absolutely. I mean, this we were talking earlier about user groups, custom groups with filters, and using antennas with filters and filters in line. A lot of that is because if you're in a very busy metro area and there's a lot of TV and a lot of RF energy, that's all coming into your front end of your antennas, regardless if you want it to or not. Without those filters, you're picking up everything, even though you're trying to listen to only a few little narrow band spikes of wireless microphones. So too much energy coming in can cause issues, possibly with whatever distribution unit that is, or just, like Adi was saying, imbalanced gain structure. A lot of times throwing a pad in the system, although it sounds like it's hurting you, is actually helping you because you're avoiding any overloads of that distribution unit or the front end of the wireless. Again, it's proportional. If you put a pad on it, you're basically lowering everything, the bad stuff and the good stuff together, but it really matters of the ratio of how much of the wanted signal is versus the noise floor, and a pad can alleviate that. Keep in mind, if you do overload those distribution units or anything else that has active circuitry, you will be creating intermods within your system. If those red lights start lighting up, or whatever model, distribution unit gets too much energy in the front end and those light up, you can create intermods that are inside of the cabling, inside of your RF distro system. And of course, then everything is trash and you're going to have a really bad time.
All right. Great. Next question. Do paddle antennas also benefit from the 90-degree orientation offset, or can they be parallel a few feet apart?
Yes.
Yeah, same. They are vertically polarized. So you treat them as a whip antenna the same way. So if your transmitter is this way, it's this way. If of course you're using them, two of them, you can put them like this, which is normally difficult because of the support that we use. We normally end up using mic stands, so we end up doing this way. And to have the best diversity, you should put them at 2 or 4 wavelengths apart. So if you're working at 2 feet wave, 8 feet, 10 feet between the antennas will be the best to get the best diversity possible. Don't put them
I love that question.
Stereo bar like this.
It's absolutely, it's a great, I love the thought process here of that question as far as doing it in the same way. Yes, it can help. In reality, do a lot of touring and broadcast applications to it. Not really. I mean, they're lucky enough to get the antenna set up on one side of the stage in time for the show, and ideally they should be on opposite sides of the stage, but usually they're over by monitor world on one side of that area and so forth. So if you can, great, yeah, all day long, let's do it. But in reality, will it still work? Yeah, it'll still work.
Okay. And next question, is there a variable antenna filter available from Shure, and where could I get one?
I love your question. We're always working on new and exciting things. So, who knows what the future may hold. But currently, there's not a variable antenna filter from Shure. There are, of course, third-party ones out there that are variable, that are fixed, and so forth, and can be used with Shure devices, along with many others. But at this time, Shure does not have one in their portfolio.
Great. All right, and I think that just about wraps up the questions. So as I said earlier, if you do have a question, you can go to shure.com/contact and fill out the form to get in touch with our application support. I want to thank you, Adi and Ben, for all the great information today, and I want to thank all of you for joining us. We hope you learned a little something. I know I sure did, and we hope to see you on the next one. Have a great day, everybody.